Hello guys, welcome to my channel. Today, in this video, we'll explore a lead screw linear motion system using a 2mm pitch screw, controlled by a stepper motor. We integrate LVGL for UI, communicate via UART, and send real-time position data back to the display. Let's see how this system works and how we can set custom movement distances with precision. The core of our system is a lead screw mechanism with a 2mm pitch, driven by a stepper motor. This setup ensures high precision in motion control. I use LVGL to create an interactive UI on the display with CYD board, allowing us to control movements easily. Next to it is an ESP32 board to control the stepper motor and send data to the screen via UART. I will describe the features on the screen. First, there's a bar to display the motor's travel distance. We can choose a unit selection button that lets us choose between 1, 10, or 100 mm increments. Once a unit is selected, pressing the increase or decrease buttons will adjust the position accordingly. For example, if 10 mm is selected, each step will move 10 mm instead of just 1 mm. This makes it easy to switch between fine adjustments 1 mm and larger movements 100 mm for different precision needs. Next to it is a notification button provides real-time status updates, ensuring we know what the system is doing at all times, whether it's moving, homing, or resetting. Here is Home button. When I clicked, it moves the system back to its home position, 0 point. Okay, next is the Run button. When you click, it will show a select panel. You can choose count, it used for wire cutter machine. Am not configured yet. You just only click Start button to run. Alright, now, I'll test the system by setting it to 100 mm. Then, I'll press the Run button and press the Start button. As you can see, motor is moving, the absolute position is updated and displayed on the screen in real time. This ensures precise tracking of the lead screw's movement, making it easy to know exactly where the system is at any moment. I'll run a test and show you how it works before we move on to the next part of the video. Please note that you should press Reset and then the Home button before running the system to ensure all previous data is cleared. Back to Squareline Studio. First, go to the File and select Project Settings. Choose the LVGL 9.1 version. Select the File Export folder. Then click Apply Changes. My interface only uses basic widgets, and I have made a previous video. You just need to go to my channel and select the playlist with the LVGL tutorial you want to watch. Next, I'll guide you on how to create a notification board. As you can see, when I click the notification button, a notification board will appear. When I click the X button, the notification board will close. Okay, on the blank screen, I add an image button widget. Select any image from the asset. Then I add a panel and customize the size as desired. I continue to add a label and an image button to make an exit button, which will hide the panel when clicked. Okay, after completing the design, I will hide this panel and start configuring the event. Begin with the Home button. Go to Event and select Add Event. For the trigger, choose Release, and for the action, select Modify Flag. Then click Add. In the Object section, I need to display Panel 8, and for the action, choose Remove. After that, click the Play button to run the simulation. As you can see, when I click the Home button, the panel appears. Next, I need to configure the event for the X button to hide the panel. I make Panel 8 visible again, then select the X button. In the Event tab, choose Add Event. For the trigger, select Release, and for the action, choose Modify Flag. Then click Add. In the Object section, I need to hide Panel 8, keeping the above settings unchanged. After that, click the Play button to run the simulation. As you can see, when I click the Home button, the panel reappears. Click the X button, the panel is hidden. This is the process of designing and configuring events to show and hide the panel. Once completed, we will export the UI and copy it into the project folder. Prepare for the next part of the video. Okay, in this part, I will talk about the wiring diagram and some notes. As you can see here, I use the CYD board as the master device. Next is an ESP32 board connected to an A4988 driver and a stepper motor. Below is the lead screw system, where I have attached a limit switch to determine the home position. For the two boards to communicate with each other, I will use UART communication combined with JSON to transmit and receive data. If you want, I can make basic tutorial videos on UART combined with JSON. Up here, I have created a microstep selection table for the A4988 driver, which you can use to select parameters that suit your needs. The entire wiring diagram, source code, and STL files for 3D printing are all provided in the video description. You can download them for reference. In this section, I will talk about the source code. Okay, so here we have two parts of the code, one for the CYD master board and one for the ESP32 slave board. I will talk about the master part first. First, go to the file UI.c, which contains all the LVGL events of the project. You can add, remove, and modify events here. Back to main.cpp, I created a struct to contain the transmitted and received data packets. This is the function that sends the data, which is packaged into JSON, making it easier to process on the receiving device. Depending on the type, it will send the corresponding data. The packaged data will be sent via MySerial. This is the function that receives data from UART. When a complete JSON packet is received, it will be decoded using deserialized JSON. If the data is postdata, it will update the position, display it on the LVGL screen, update the label and progress bar. Next is the function for interface control and button signal processing. If the start button is pressed, it sends motor data to update the distance and steps. If the home button is pressed, it sends home BTN. If the reset button is pressed, it sends reset BTN. Always call receive motor data to function to update the real-time position. Moving on to the code part of the ESP32 slave, you must declare the GPIOs of the limit switch, step motor, and configure steps and microsteps according to your needs, based on the wiring diagram I provided. Similar to the CYD master board, I also created structs to contain the data packets. This function is used to send the current position of the motor to the CYD board master via UART. This function calculates and converts the distance to steps according to the lead screw system. This function controls the motor to run to the set distance and assigns the position to the send position to master function. This function processes the home position using the limit switch. This function processes and receives distance, steps, home, reset commands from the CYD master. So, I have briefly reviewed the functions in this project. The download link is in the description below the video. I will end the video here. Thank you for watching. If you find it useful, don't forget to leave a like, share, and subscribe to the channel. I wish you success in this project, and see you in the next video.